Welcome back, learners. Today's session we are going to discuss about the syllabus and modules in where what exactly we will be learning about in each modules. So the syllabus is divided into three sections. The first one is internal architecture, second one microprocessor programming, third one is interfacing. Dividing these into modules, we have five modules. The first module will be on microprocessor architecture. Second one will be on ALP programming. Third one will be on memory interfacing. The interfacing part is divided into three parts. One part is memory interfacing. Another part is IO interfacing part 1. Another one is IO interfacing part 2. Module 1. What you will learn in the module 1 architecture, internal architecture. First one, internal architecture, you will be studying about address decoding unit, execution unit, arithmetic logic unit, and instruction decoding unit, etc. Also, already as we discussed, CPU is not by itself can do anything, but though it has lot of computing power. So we need to connect it with some memory and IO also. So those IO connections are divided into two sections, memory mapped IO and IO mapped IO. So these two things, what exactly it is, we will study in the first module. And also tri-state, there are simple input output modules, which is called tri-state buffers and latches. We will study about that, even though input output are like display and keyboard. So the basic unit input outputs are tri-state buffers and latches. Next comes memory addressing. The microprocessor has address lines. Using these address lines, we can address a lot of memory sections, and there are different types: flat memory addressing, real mode addressing, which is used in DOS operating system, and protected mode addressing, which is used in Windows operating system. And then comes the bus architecture. You know, buses for transportation. Similarly, in microprocessor also, buses are used to transport the data or address from CPU to any IO devices. So that we will be studying in the first unit, first module. Control buses are something like, even in memory, it is not one operation. We can read or write. So somebody should give a control signal whether we are going to read or write. So those things also we will be studying about in the module 1. Module 2, microprocessor programming. So in order to have the programming, in order to be efficient in assembly language programming, two different things are very crucial to understand. That one is register organization and another or programming model. Another one is addressing modes and instruction format. What is register organization? The small memories are there in the microprocessor, though the bigger memories has to be externally interfaced. So the smaller memories are general purpose register, stack register, flag register, program counter, and some more thing, etc. These registers, what are their width and how and what it will do, we will study. In addressing modes, and there are multiple memory data will be there, and instructions also will be there in that memory. In order to retrieve the instruction, or in order to retrieve the data, or in order to write the data, there are different addressing modes are used. Those are called register addressing, register indirect, absolute addressing, immediate addressing, etc., etc. And the new addressing modes compared to 8085 is indexed addressing and relative mode addressing. Combining these two, anyone can you write, and also before that, instruction formats. There are data transfer instruction, flow control instruction, logical instruction, arithmetic instruction. There are many things are there. All those things we'll be discussing in the second module. By combining these two, anyone having the logic mind can easily write assembly language programming. But what we will teach is 32-bit binary multiplication and division, 32-bit addition, BCD addition and subtraction, linear search, binary search, array addition and subtraction, etc., etc. Maybe in the assignments, you will be asked to do more. Third one is third module is memory interfacing. As we all know, memory, there are different memories, SRAM, SDRAM, DRAM. All these things need a different type of interfacing so that the hardware circuits we will be dealing, and also in order to have selecting one memory chip out of multiple memory chips connected to the microprocessor, there must be an address decoding unit. Those address decoding units are multiple types. One is simple NAND decoder, line decoder. This simple address decoding also is there. All these things we will be discussing in module 3, memory interfacing. Next comes I/O interfacing part 1. So what do you do in I/O interfacing part 1? There are input-output devices. Keyboard is input, display is output devices. Timer interface and interrupt controller are in general. We will be studying all these things. Keyboard interface, it's not possible to deal with a computer keyboard. So for example, we will use a 4x4 key matrix interface. And how the pressed keys are scanned and it is identified, we will discuss. And there are other methods called lookup table method. All these things we will be discussing, and corresponding development of assembly language programming we will be discussing here. In display interface also, minimal display size, 8-digit LED display size interface, how it is done, and also assembly language programming, LCD, newer display devices, LCD device, and how it is done using assembly language programming we will discuss here. And timer interface, one shot generator, rate generator, these all things, if you remember, you would have studied in 555 timer in analog electronics or integrated electronics. So same kind of timing signals can also be generated digitally, that is using the timer interface. Interrupt controller, normally to connect with any I/O devices, polling method is also there or interrupt also there. But interrupt only with the microprocessor are very minimal. So we have to study about interrupt controller, which expands the expanding the original number of interrupts available with the microprocessor. So for those cases, command input and everything, we will study how to write the interrupt service routine. Also, we will be studying in this part. Part 2. Part 2 is actually about a little bit higher interfaces, which is communication interface, DMA controller and video controller. What is the communication interface? It is the connection between one microprocessor and another microprocessor as a system can be done by communication interface. So here, what is the data format like MSB first or LSB first or 7-bit or 8-bit, etc. Like how to do that we will do, and also setting the baud rate, that is the speed of the communication between one processor and another processor we will discuss. All this corresponding ALP code also we will develop. So DMA controller. So independent of CPU, there can be a transfer of chunk of memory from one memory to the another memory. That can be done by DMA controller, which is called direct memory access controller. Here also, what are the command registers available and different modes of operation available. Any interfacing will have many command registers and different modes of operation. All these things will be studied with the help of a ALP code. And the video controller, oldest CRT monitor, and recently like video RAM or coprocessor, all these things we'll be studying. As a whole, after studying this, we'll be able to design a system either with a microprocessor or with a microcontroller. Thank you. Happy learning.